All right, so we're going to use the conjugate pair theorem to help us work through this problem. And this will be our first example where we're going to use synthetic division with a complex number. And it's a pretty straightforward process if you understand how to multiply, add and multiply complex numbers. So anyways, yeah, let's see how this works out. So we have 2 plus I is a 0. That's given to us in the problem, which is really convenient because that also gives us another 0 by the conjugate pair theorem. So if we know that one of our zeros, so I'll put zeros because we're going to find more of them. If we know that we have 2 plus I, that's a 2, 2 plus I is a 0, then we also know that its conjugate, or also known as a complex conjugate, will also be a 0. So 2 minus I. And you'll notice that we've already worked out a problem in the previous video where we had we found the zeros involving imaginary numbers back in example 1a, and we worked that out and we found that we had I don't quite remember, but I believe it was like 2i and negative 2i. Notice that those are complex conjugates. Um, it just didn't have a real number part. So it just had the imaginary part, 2i and then negative 2i. You'll have, yeah, so you'll notice that they'll always come in pairs. So we have 2 plus I and 2 minus I. And now we want to use these two results, these two zeros, to find how to, well, we're trying to find all the zeros. And so we want to find the remaining zeros. There's still more zeros out there. And so, yeah, let's go ahead and work this out. And the reason we know that there's more zeros is because this is a fourth degree polynomial. So we know that we're going to have 4 linear factors. So yeah, so let's work this out. We have 2 plus I. And we're going to have 1 and negative 4, 14, negative 36, and 45. And so we were going in descending order, and we didn't have any skip terms, so it goes 4, 3, 2, 1, and 0. So we don't have to have any spacers, any zeros in here. And we're going to add down, so that's just 1, and then we're going to multiply up. So 2 plus I times 1 is 2 plus I. And then we add negative 4 with 2 plus I, so that just gives us negative 4 plus 2 is negative 2. And then there's nothing with I to add. So then we go 2 plus I times negative 2I. So we can do that on the side. So 2 plus I, actually I'm going to do that down here. So this will be kind of scratch work on the side. 2 plus I times negative 2 plus I. That will give us 2 times negative 2 equals negative 4. 2 times I is 2I. And then I times negative 2 is negative 2I. So those cancel out. And I times I squared. And then we know how to simplify I squared. That's equal to negative 1. So negative 4, and this is equal to negative 1. So that's negative 1, and that gives us negative 5. Okay, so that's so when we multiply 2 plus I times negative 2I, we get the result up here, which we found is negative 5. Very good. 14 plus negative 5 is 9. And 9 times 2 plus I is 18 plus 9I. So we'll have to remember we have to distribute 9 through the and multiply by both those terms. Okay, negative 36 plus 18 plus 9I. And so that would give us negative 18 plus 9I. Okay, All right, so we need to now multiply 2 plus I by negative 18 plus 9I. And so that gives us negative 36. 2 times 9I is plus 18I. And then we have, where am I? I times negative 18 is negative 18I. Those cancel out, which is good. And then we have I times 9I. And actually, at this point, I just realized we don't have to, we know 2 plus I is a 0. So we know that this is going to come up with negative 45. We don't actually have to do this because we know it's a 0. We know that when we add it, it's got to be 0. Okay, so hopefully you understand that. Since we know this is going to result in a 0, we already know what this is going to be. So I should have noticed that before. Now we're going to take this result, and that's our new coefficients, and we're going to use 2 minus I now. And I'm going to copy these over. So 1, negative 2 plus I, 9, negative 18 plus 9I, and we're going to use synthetic division again. So because we want to factor this further and figure out, using both of these zeros, what will we result with, our ending result be. So 1 times, okay, so that's 2 minus I. 2 minus, oh, whoa, look at that. That adds up to 0. And then we have this multiplied together. That's just 9 when we add it down. Okay, and then this will result in a 0 remainder again, so that must be 18 minus 9I. Okay, yeah, so there we go. We knew this was a 0, so I knew what this was going to end up being also. So this will give us, this is x squared from, so it's like 1x squared, and then this will be plus 9. And I know that this is a second degree polynomial because we had fourth degree, so this was third degree, and this is second degree. It always decreases by 1 when you use synthetic division. All right, so we now know, just to show where we're at, p of x is equal to x minus 2 plus I, x minus 2 minus I, from these two zeros here, and then multiplied by this right here. But we still need to go further because we need to find the remaining two zeros. So we're going to use x squared plus 9 and set it equal to 0 because it's a 0. We're going to find that 0 by setting what we have remaining to factor. We're going to set that equal to 0, and we're going to solve. So we have x squared equals negative 9, and then we have x equals plus or minus the square root of negative 9. And that gives us x equals plus or minus 3I. Okay, we found the remaining two zeros. So that's 3I and negative 3I. And there we go. We found the 4 zeros. And see that the final two zeros ended up being conjugate pairs. So notice that we had 3I, so we must also have negative 3I. So we have two pairs of conjugate. Yeah, so we have two conjugate pairs as our zeros. So hopefully this makes sense. Let me know if you have any concerns about this process, and I'll be more than happy to help. And also, do keep in mind that it is possible to have rational real zeros. In this case, we just happen to have all imaginary zeros. It just happened to be that way. But it could have been possible that we would have had real zeros for the last two, but you never know. All right, let me know if you have any concerns.